Good day once more, Matrix, wherever you may be. Guys, I want to believe that genetics is been now making sense to you. I know you may not actually understand everything at once, but believe me not, if you keep on trying and do more activities, especially practicing examination questions, surely you should actually get it right. Yeah, we will actually try to also practice. Once we are clear with this, we will try to practice more questions so that we can understand this topic deeply. Right, we're continuing once more. Now we're doing lesson 7 of genetics and inheritance. And today, as you can see on my screen, we are looking at the sex-linked traits. Sex-linked traits. So what are sex-linked traits, which are also characteristics? These are characteristics carried on the gonosome. Characteristics characteristics on the gonosome. So these are called sex-linked traits. Now, where on the gonosome, especially on the X chromosome. So these are characteristics that we'll be discussing. They are carried on the X chromosome, meaning that the Y chromosome does not carry anything as of now, right? So two types that we can identify according to the prescribed content of your examination guideline. There are two types of sex-linked characteristics. We have e.g. one, we have color blindness. Color blindness or color blind. Number two, we have what we call hemophilia. So these are two prescribed sex-linked characteristics. Guys, be very careful. You know, there are only two prescribed sex-linked characteristics in your or for your examination. However, the examiner can still bring other sex-linked characteristics that you may not have done in class. Therefore, if they bring a sex-linked that you do not know, they will always mention it in the statement. Okay? There are so many sex-linked excuse me. There are so many sex-linked characteristics. However, as of now, stick to this. What is important is to understand the skills on how to attend to such questions, so that if they bring a question that is away from what has been prescribed, then you'll be in a position to answer those questions, right? Okay, so let's look at it now in detail. Colorblind. We're going to deal with only one, because once we do with one, then it gives you a ability to be able to understand the other one. So let's look at colorblind. What is colorblind? Colorblind is a condition that results due to absence of a protein. Absence of a protein. A protein that forms the cones, that forms the the cones. Remember, in your eyes or in our eyes, we have cells, special cells there on the retina, particularly on the yellow spot there. They are actually the photoreceptors that are sensitive to light. So these cells are called cones. So these cones are made up of a protein. So if this protein is absent, then it means a person is going to be color blind. Okay, so if this protein is absent and that a person is colorblind, an individual will not be able to distinguish between two colors, e.g. green and red. An individual may not distinguish, that is to differentiate, distinguish between red and green. So it means a person is colorblind. Now, what I wish to indicate also is that this colorblind is caused by a recessive allele. It is caused by a recessive allele on the X chromosome. So we normally write it like this. So this is the recessive allele. The recessive allele X with a small letter B is the one that causes color blind. Now let's look at the possibilities. We'll use a table here to be able to determine the possibilities, right? Here's my table there. I'll do this. There we go. I have my table. So in this table, I want us to look at this is going to give us the genotype, right? And this is going to give us the phenotype. Remember, the phenotype is the physical appearance. Okay, so let's say, what is the possibility of males and females having color blind? Remember that males are XY, right? XY. So meaning that males, the genotype can be this or can be this. So when a male represents that, it means this one is normal. It's going to be a normal male. It's a normal male. A normal male has a dominant allele on the X chromosome. What about this one? Because this one has got a recessive allele, then this one is going to be affected male. This one is going to be affected, or we can say is a color blind male. Now remember, you must always indicate the phenotype, color blind male or affected male. Now let's look at this. There is no any other way we can write the male. So a male can either be normal or can be affected, because there is no any other combination that we can. If I can write XB again, it will mean the same one again there, because on the Y chromosome we don't indicate anything. Very important, guys. So let's look at the females. We know that females are XX. Right. Females are XX on their gonozome. So if a female has XX, its possibility or the combination can be B there and the B there. This woman is going to be normal female. Okay. Or it can be XX. Then a woman who have a dominant allele there. Then here I won't write dominant because I write dominant to be the same. I will write the recessive allele that way. So this woman will still be normal. However, because she's got the recessive allele there, this woman will be a carrier. So we can say a normal female who is a carrier. It's normal female who is a carrier. Now, look at this, guys. Why is this woman normal when she has the recessive allele present in the genotype? Look, the genotype has a dominant allele. So this dominant allele, it masks the recessive allele. So the recessive allele will not actually be expressed in the phenotype because it is going to be masked. Okay, so a female can also be XX this way, but in this case, the only way now that I can indicate, I can say B and B. Remember, you cannot say X, B, X, B. This will still give you this one there. You can see that this is the dominant allele. So this arrangement is the same. So you cannot actually change it. So the only combinations are these. So the last one there, this individual has got two recessive alleles. So we're going to say this is an affected female. Affected female. Very important, Gansan. Now, let's look at the possibilities of having colorblind. You can see now, out of 2 in males, 1 is affected. You see, out of 2 males, 1 is affected. But what about females there? There are 3 females there. Out of 3 females, there is only 1 that is affected. Now you can see that color blindness here, it affects more males than females. Why? Because males have got only 1 X chromosome. So if the X chromosome is a carrier of a recessive allele, then the male is going to be color blind. If there is a dominant allele, the male is going to be normal. So in this case, a male can either be normal or affected. These are the only options, no any other options. But what about females? A female has 2 X chromosome. Therefore, a female who is heterozygous, like this one, the female, I know you say 1, with 2, with the female number 2 will not be affected. Why? Because much as she is a carrier of the recessive allele, she will not be affected because the dominant allele always masks the recessive allele. So in this case, it implies that a female needs 2 recessive allele to be affected. That's why you see that females are not actually mostly affected by this sex linked. That is, it gives 2 females who are not normal. Look at this one and that one. There is only 1 that is affected. So out of 3 women, you've got 2 who are normal and 1 that is affected. So this is very, very important, guys. Very, very important. Now, okay, let's look at question that would do. Right, look at the question. Here is a typical examination question. Now, as you can see there on the screen, we're going to look at question number 24. Question number 24 reads as follows. Says, in humans, hemophilia is caused by a recessive allele on the X chromosome. X recessive, as you can see there. A woman who is heterozygous for hemophilia marries a man with hemophilia. Then says, use a genetic cross to show the percentage chance of the couple having a daughter who is homozygous for normal blood clotting. Right? Now, one would be wondering to say, oh, no, what is hemophilia? Hemophilia is a condition where an individual has abnormal blood clotting or the blood cannot clot properly. So a person with hemophilia always or bleeds continuously, which tells us that hemophilia is a condition where an individual bleeds continuously. Now, why am I using this question, hemophilia, and not colorblind? Remember, the application of this content is the same. What I explained is the same as who do this question. Okay, now let's do this. Right, so in answering this question, we all know that we always have to have the P1 generation, which is the phenotype, and we have got the genotype, and you're going to have meiosis. Then you're going to have gametes. Then you're going to have fertilization, and then we're going to have F1 generation there. F1, which is going to have geno and pheno. Right, so my pen is running out. Okay, now let's look at the question again. So we've been told that hemophilia is caused by a recessive allele. So in this case, we have to use the X chromosome, X and Y, because this is a sex-linked characteristic. Okay, so we are told also that a woman is heterozygous. So we must underline with a pencil the heterozygous. So what does it mean, the heterozygous? If a woman is heterozygous, it means that in her genotype, she's going to have different alleles that way. So when she is like this, remember the way we wrote it. Sorry, I think this is wrong. We're going to use H. Sorry for using a B, because we are supposed to use H. We have been given the letter H. So in this case, we have to use the letter H, which means that here I will use small letter H. Now, this is still heterozygous. So being that is heterozygous, this person, what is the phenotype? The phenotype, this means that this person is normal. If you remember the previous table, though, the previous table that I was looking, that I used in my example, was talking about color blind. Now, the color blind was we were using the letter B. So here we're using the letter H. So cross. What is the question saying about the father? Marries a man with hemophilia. So meaning that the man is affected. So we're going to say the phenotype is affected. Affected male. And here it should be normal female. normal female marries affected male. Please, I don't have space there. I should have indicated they're female. So we all know that males are XY, isn't it? So on the X, because he's affected, is going to have who? The recessive H. So what happens here is that there's going to be meiosis. And when meiosis forms, the female is going to have two gametes. And the male is going to have two gametes. So in here, this X with the dominant H will be there. And the X with the recessive H will be there. And this X with the recessive H will be there. Then we're going to have Y there. So which means now that when we close this, we're going to have that and that. It will give us X dominant plus X recessive. Then give us also this and that is going to give us X dominant and Y. Again, which is going to give us, that is this and that. Then it can be this and this. It's going to give us X recessive, X recessive. Right? Then lastly, it can be that X recessive and the Y. So you're going to have X recessive and the Y. Clear? So let's look at the phenotype. You can see that this female is normal because there's a dominant allele. So we're going to say normal female. Right? What about this one? This one is going to be normal male. Normal male. Remember, when you are giving the phenotype, it should accompany the gender. Once you leave out the gender, then it means your answer is incomplete. What about this one? It's going to be hemophiliac female or affected female. And this one also is going to be affected male. So that is going to be a phenotype. So now the question says, use a genetic cross to show the percentage chance of the couple having a daughter. You underline daughter, who is a homozygous for normal blood clotting. Homozygous for normal blood clotting. Now, you know, if a daughter is to be homozygous, it means the daughter needs to be like this, because the word homo means same. So now when you look at the females, we have only two females in this. This is a heterozygous female, and this one is a homozygous female. But here we want a daughter who is homozygous for normal blood clotting, meaning that this female shouldn't be affected. So it should be like this. So do we have the child here that is normal blood clotting? No, because we don't have the homozygous one. So therefore, it's going to be 0%. So your answer in this case is going to be 0%. So if they were to ask you to say their chance for their daughter to having abnormal blood clotting. So we've got only one daughter that is has a abnormal blood clotting. So we're going to say 1/2, because there are only two daughters there, of which is going to be times 100, and it gives you what? 50%. It's going to be 50%. However, this is just, I'm just adding in case just to expand your understanding. But the answer in this case, it will end here at 0%. Okay, so I think I would rather cut it short for now, and we are going to continue in my next lesson. What you can do is you can find a question in the past exam paper which has a sex linked, and try to answer the questions. Remember, the application is going to be the same. Okay, good day.